So let's start the exercises, and let's start with number 2. There is another part B, we will see that afterwards. And the question here is this: for what characteristic of the field F are the following determinants 0? There are two determinants, the first of which is this. We have to figure out the characteristic of the underlying field from where these numbers are coming, so that this determinant becomes 0. Although these numbers look like, maybe I should not say numbers, but these entries look like real numbers, but do not forget that they are general field elements. What is the meaning of 2? 2 is 1 plus 1, the unit element in the field plus itself. 3 similarly is 1 plus 1 plus 1. So that's the interpretation of these real number looking objects. Okay, so now we have to first of all calculate the determinant and then say what the characteristic should be so that it becomes 0. We start the solution by naming the given determinant capital delta. You can call it anything, but I have just written delta. Now delta equals this other determinant which we have obtained from the given determinant by going through a row operation. And one of the results we saw back in the section tells us that we can do this without altering the value of the determinant. What specific operation did we apply here? We multiplied the third row by -6 and we added that product with the fourth row. Let's first see what we get from that operation and then we will say why we did this thing. So if you multiply the third row by -6, that means multiplying each entry by -6. So after you do the multiplication, you will have here -6, -6, -6, -6. And then if you do the addition, this one plus this one, not exactly this one, I mean the one having -6, then what will you get? Because addition happens entry wise, -6 plus 2 is -4, -6 plus 4 is -2. -6 plus 5 is -1 and -6 plus 6 is 0. But why suddenly this specific operation? Well, the observation here is that the fourth column of the original determinant already has 2 zeros and we want to see if we can create more zeros. To do that, we observed that -6 plus 6 is 0. So that is why we did this. And now we have the fourth column which is almost 0 except for this one. And so now in the next step we can expand this determinant using the fourth column. Now how does that expansion go? To do the expansion, you have to take these, actually strictly speaking you have to take these zeros also. For this entry 0, for example, the corresponding term in the expansion would be this. What is the position of this entry in this determinant? It's in the first row and fourth column. So you will have to write -1 to the power row number plus column number 1 plus 4 times the entry 0 times the next lower order determinant which you get from this larger determinant by removing the row and column that has that entry, which means that -1 to the power 1 plus 4 times 0 times this determinant 3, 2, 1, 1, 1, 1, -4, -2, -1. But because 0 is there, so that ultimately vanishes. Similarly, the term that you will get in the expansion because of this 0 and because of this 0, those two terms also won't be really there. So you just have to write the term in the expansion corresponding to this entry 1. What is the position of this entry? It's in the third row and fourth column. So we have written -1 to the power row number plus column number times the entry 1. Although it won't really make any difference whether you write 1 or don't write 1. But just for the sake of this form, the form in which it originally appears, I have written 1 so that we do not forget. And then what do? Then we remove the row and the column which contains this entry, and the remaining entries give us a 3 by 3 determinant. The original one is a 4 by 4 determinant, this is a 3 by 3 determinant, and that is 1 to 3, 3 to 1, minus 4, minus 2, minus 1. In the next step, you can of course see that because this is 7 and 7 is odd, so you have minus 1 outside. We have just written minus. Now if you want, you can expand this determinant as it is fully, but instead we see if we can create more zeros so that our job becomes easier. Yes, we can actually, and we can do that by adding rows. We have gone through 2 row operations here to get this one from this one, and those 2 operations are these. We have added the third row to the first row, and that became the new first row. Do we see that minus 4 plus 1 is minus 3, minus 2 plus 2 is 0. It is because of this 0 that we did this operation. Minus 1 plus 3 is 2, and we have also added the third row to the second row. Doing that, we have got minus 4 plus 3 minus 1, minus 2 plus 2 0, and an extra 0 has also appeared, minus 1 plus 1, that is 0. Although originally we just observed that here we can create zeros. Because we have used the third row to do these operations, the third row remains as it is. So now how can you think of expanding this one just like you expanded this one? You can expand this one conveniently by doing the expansion with respect to the second column. So the terms in the expansion corresponding to these 2 entries will just simply be 0. So there is no need to even consider them. You just consider the term corresponding to minus 2. So we do the expansion in the next step. And what is it we have to write corresponding to minus 2? First of all, you see the position of the entry minus 2 in this determinant. It's in the third row and second column. And because of that, you have to write minus 1 to the power row number plus column number, 3 plus 2. But do not forget that outside you already have a minus sign. So we have the minus sign, we have this power of minus 1 times the entry minus 2 times the next lower order determinant that you will get from this one by removing the row and column containing that entry. So removing the row, this row and this column leaves you with minus 3 to minus 1 and 0. So that's how you have this 2 by 2 determinant, which is, this one you can just simply expand. And to make the job even easier, there is a 0 also. Okay. Now what are we getting from this? You see, here we have minus 1 to the power 5, that means minus 1. Times minus 2 is 2, but already there is a minus sign outside, so that means minus 2. And the expansion of this 2 by 2 determinant you have here. Minus 3 times 0 minus 2 times minus 1. Like this, this. Okay, this times this minus this times this. And you can see that this is 2, minus 2 times minus 1, and outside you have minus 2. So you have minus 4. Now we want this minus 4 to be equal to 0. Again, do not make the mistake of thinking that this is the real number minus 4, which of course is never 0. This is minus 4 in a general field, and that will happen, that is delta will be 0 if the characteristic of the underlying field is 2. And do not say that the characteristic is 4, because you recall that result from ring theory. The characteristic of an integral domain which has finite characteristic, not 0, is always a prime number. That is why 2 is the only option. Next comes part B, where we have the same question, but this time we have this 3 by 3 determinant, again with the entries actually coming from our underlying general field F. We have to figure out the characteristic of the underlying field to make this determinant 0. So here also we start the solution by naming the determinant, say delta 1. Now I have decided to just simply expand the given determinant as it is. If you want, you can try to create zeros, but you have to do you have to go through a lot of row operations, maybe even column operations, but then also you will may be able to create only 1 or 2 zeros. So that much work is not justified simply for creating zeros. So that's why I have decided to just simply expand the determinant using the first row itself. Let's see the expansion. First, there will be a term corresponding to this entry 3. The position of 3 is first row, first column. So minus 1 to the power row number plus column number times the entry 3. Now if you remove the first row and first column because they have this entry 3, then what are you left with? 5, 3, 3, 4. So that's how you also multiply with these things the next lower order, next or previous, in any way you can call it, anything you can call it, 5, 3, 3, 4 determinant, lower order determinant. And then what will be the term corresponding to 4? Its position is in the first row, second column. So minus 1 to the power 1 plus 2, row number plus column number, times 4 times. Now what will the 2 by 2 determinant be? That you will have if you remove the first row and second column because they contain that entry 4, and then you will be left with 4, 3, 5, 4, 4, 3, 5, 4. Similarly, for this 5 also, which lies in the first row and third column, we have minus 1 to the power 1 plus 3 times 5 times. Removing this row and this column gives you 4, 5, 5, 3. Alright, and now we can continue the calculation. Okay, so next we do the calculation. What is this? Well, what is this first? This is plus 1 because 1 plus 1 is 2. So that means we will have 3 here. And this one is 5 times 4, 20, minus 3 times 3, minus 9. Just like that, this next one will be minus 1 because 1 plus 2 is 3. So minus 4 is outside, and inside we have 16 minus 15. And for this one, we again have plus 5, 12 minus 25. So this becomes 3 times 11, and this one is very easy because this one is 1. So minus 4 times 1 plus 5 times, this is minus 13. That means 33 minus 4 minus 65, which becomes minus 36, which is minus 2 square times 3 square. So this time, because of this value, we have two options for the characteristic of f that will make this equal to 0 in the underlying field f, and those two values are 2 and 3. Again, remember that it can only be a prime. So if the characteristic is either 2 or 3, then delta 1 is 0.